Okay. So as I was saying, linear programming problem, we have formulation of linear programming problem. That is, whatever is given to you in the terms of verbal communication, this needs to be converted into mathematical equations. Okay. So all this needs to be converted into mathematical equations. Is it visible, student? Hello. Please somebody respond.
Audible, but it is slow, sir. Voice is
Okay. The screen is visible now.
yes, sir, visible.
Okay, good. So as I was saying, so mathematical equations need to have the essence of what is there in the verbal communication. Now, what I need to say here is the term formulation refers to the process of converting verbal description and numerical data into mathematical expression, which represents relationship between various relevant variables and objectives and constraints on the scarce resources, that is labor, material, time, machine, warehouse, capital, energy, etc. So whatever we have, that needs to be converted into equations based on this function. So when we talk of formulation, we need to understand that there are three things. One is called the variables. These are called decision variables. Variables or decision variables. Okay. Then we have objective function. Objective function. Then the third one is called constraints. Okay. So when we talk of formulation, we need to convert whatever is given in the verbal equation, verbal communication into the decision variables. So what is the decision variable? Decision variables are the course of action, course of action or alternatives. Okay. And what is of objective function? The goal that you want to achieve or the objective or the aim. You can call it by any name. And the constraints are the limitations, limitations on resources such as math, material, machine, energy, or money, etc. It can be anything. So we need to convert our equations such that they have the essence of what are limiting materials. Based on those limiting materials, what are the courses of action available to us and how can we can achieve the objective function. Okay. So this is known as linear programming problem. Now, why we are calling it a linear programming problem? If you see this term linear programming problem consists of three words. First is linear, indicating the relationship, indicating the relationship between variables. What is the relationship between the variables? That are these variables are linear in order, having linear relationship between one another. That is, Say for example, if we have a variable x1 and a variable x2, they will be of the order x1 and x2 only. There will not be any x1 square or x2 square. Okay, this is quadratic. This is linear. So the relationship is linear. This is quadratic. Okay. So the first term, linear programming problem, indicates that there is a linear relationship between the variables. Second term, programming means you need to follow certain steps to achieve a achieve a solution and problem, that is solution required. Okay, so what we have here is a linear programming problem in which we need to formulate a problem based on certain steps. We will achieve solution, and the relationship between these variables are linear. Okay, now let us proceed to general structure of. Let me add one more page. So next is structure of LPP, that is linear programming problem. So as I said, there are three things. One is called, first one is called decision decision variables. Decision variables. Okay. Decision variables is the evaluation of various courses or alternatives to arrive at the best optimal solution is known as decision variables. Okay. Now these decision variables will be denoted by denoted by x1, x2, x3, x4, and xn. Okay, where these values are always equal to or greater than equal to 0. Why this is so, we'll discuss it later. I'll tell you why this all needs to be greater than equal to 0. But for now, you understand this, that all these variables must be greater than equal to 0. Why this should be greater than equal to 0, I'll tell you later when we'll discuss about the formulation of the problem. So then these variables are controlled variables or uncontrolled variables. So controlled variables are when these variables have a limiting on their value. If there are no limits on the value, then it is uncontrolled variable. Okay. Then next thing what we need to understand is objective function. Objective function. So objective function gives the aim or goal that you want to achieve for a particular problem. So it can be profits to be maximized, or it can be cost to be minimized. Now, why I have taken these two examples is I want to tell you that the objective function can be a maximization problem. Maximize z. Objective function is normally represented by z. Though some books may have different notification or nomenclature, you may refer to different terms. But for me, I'll always use objective function as maximize or minimization of z. Okay, so this is up to you which uh, method you want to follow. As I said here, the decision variables I'm using x1, x2, x3, x4. Some people may use c1, c2, c3, c4. That is up to them. Okay, but for us, we will be using x1, x2, x3, x4, and xn as the decision variables. Similarly, for objective function, we will have a function z, which will be indicating the aim or goal of the function. But here, what I want to emphasize is do not get this into your mind that whenever we talk of objective function, it is always a maximization function or it is always a minimization function. It can be dependent upon the conditions or it can be dependent upon a particular problem, whether we want to maximize profits or whether we want to minimize cost. Other can be minimization of time required, minimization of time, minimization of time required for processing. Okay, so there can be various examples required for time for processing. Sorry, for processing. Okay, hello, is it audible, students?
Yes, sir.
So I hope
Yes,
up
sir.
to this point the things are clear. When we are interested in converting the linear programming problem, these two things are very important. The last thing that we need to understand is a constraints. The last thing is constraints. So when we talk of constraints are the limitations, limitations on resources. Now, best example of this limitation on resource just came onto our screen that we have limited time. We have only 10 minutes spent in this session. So this is the limitation. This is one real example that you can see as of now, that the limitation is on time, limitation on resources, limitation on man, material, machine, energy, okay, money. You do not have unlimited resources. For example, if I'm going to start a business, I will have some amount of startup money that I'll be having, some initial investment. I cannot go beyond that initial investment. So we have to make sure that, sorry, just one second. Hello. So, as I was saying, we have limitations on the resources. Now, uh, so let us take one example that way it will be easier. Okay, before going to example, let me just give you a generalized mathematical model. General. So generalized mathematical model of LPP. Okay. When I talk of generalized mathematical model, I'll write first objective function. First thing I'll write is objective function. So when I write objective function, it needs to be optimized optimize, that is maximize or minimize, z, okay, z is equal to c1 x1 plus c2 x2 plus c3 x3 and so on up to cn xn, where x1 x2 x3 xn are the decision variables and c1 c2 c3 cn are the weightage of that particular decision variable in the objective function. So what is c1? C1 is weightage, weightage of x1 in objective, in objective function. Got it? Any doubts in this? Hello? Students, any doubts in this? Is it clear? Hello? Please respond, students. Is it understood? Hello?
Yes, sir.
Okay. So let me just rub it here. So first thing we write is an objective function. So objective function will be a combination of your decision variables and their weightage in the objective function. So I've written c1 x1 plus c2 x2 plus c3 x3 and so on. Now, if after this we need to write that they are subjected to this objective function is subjected to constraints. Which constraints? So these objective to constraints such as a11 x1 plus a12 x2 plus a13 x3 dash 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 plus a1n xn should be greater than equal to sorry, should be less than equal to or equal to or greater than equal to b1. Now why I have used three different terms here? It is whether the resources have a limitation on the upper end, whether the limitation is exactly equal. For example, I may use for an institute, I may use some number of teachers. For example, it is say 5. That is B1 is 5. So the total teachers required in different classes should be less than equal to 5. If I have that minimum 5 teachers are to be used, then I'll write that it should be greater than equal to 5. If I say that only 5 teachers are to be used, then we'll be using exactly equal to. So any constraint can be of these three types. It can be less than equal to, it can be equal to, it can be greater than equal to. This means it can also be exactly less than, may not be equal to, should be less than 5 only, should not be equal to 5. You cannot afford 5 teachers, you should afford only 4. So it is either less than or equal to or greater than or equal to or exactly equal to. So this depends upon the constraint. This is first constraint. Then the second constraint will be a21 x1 plus a22 x2 plus a23 x3. Similarly, that plus a2n xn should be greater than, less than equal to, greater than equal to b2. and this will go on up to a m1 x1 plus a m2 x2 plus a m3 x3 dash plus a mn xn should be less than equal to or greater than equal to bm. What does this indicate? This indicate that there are n number of constrained variables or decision variables, and there are m constraints. This indicate that there are m constraints. This indicate that there are n variables, n variables and m constraints. Okay. And then other than this, they are also subjected to other than this, they are also subjected to x1, x2, xn should be always greater than equal to 0. This is called non-negativity constraint. Now, why this is used? I think we'll be ending this session now. After this session, again we'll continue tomorrow.